But let's get to the business as usual. So this morning, a lot of students sent me a lot of questions that they need some help from me. So I thought, I'll try my best to help, the basic code. So of course, you may identify my mistakes, little mistake here and there, and also you can learn from it. So whenever you identify the mistakes, anything you want to talk, just feel free leave the comments under, and don't forget to subscribe. So feel free anytime. You know how to get me, right? You can also give me a ring. So let's get started. So let's go to the first question, right? So it's the first question right here. Excuse me. Unfortunately, I don't know. It's a lot of pages, man. It was like 30 pages. So they're saying to me. So I didn't. It's a lot of. It's very expensive for me to print all 30 pages. So what I did, I asked one of the guy, in my next door, if he could borrow me his computer, and then I can browse this question from the computer. The program that I use there to record this question, it doesn't allow me to browse straight from the computer. Or probably I'm one of those, people who don't know how to use computer. You never know, man. Maybe I'm so bad at technology, so probably somebody could advise me, which type of software that I can use, so that I could be able to record or I could be able to browse questions straight away to my computer. So let's go without wasting time. Let's go straight to the first question. Okay. So the first question, excuse me, just a second, please. Okay, so that's the first question right here, right? So the first question, excuse me. So that's the first question, right? They say, excuse me. Let me just bring this computer much closer and closer so that everybody can see. Excuse me. So the first question say, which of the following is true? So we got da 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 da. I hope everybody can see. I'm trying my best, man. But like I say, okay. So that's the first question, and you have to prove which is true. I hope everybody can see that question. If you don't, please let me know. Okay, let me try to maximize more so everybody can see. Probably maybe some people cannot see. We got some other people like me who have some, visual problems. So we have to prove that's first one. If it's true, it's not true. Left hand side equal to left hand side. And then let's take the second one. Okay, that's the second one right there. So given x equal negative a half and then x equal y equal to negative 2. And they have to prove that one. The third one. Okay, quick time. Okay, so they say defined for all x. This function is defined for all the value of x a real number whereby x is not equal to 1, and those are options right there. Okay, let's go to the business as usual, man, without wasting time, because time is money. So let's go. Let me take a page quick. Take my pen. Take them quick without wasting time. Okay, let's break this first question. Okay, so the first question, okay, so the first question, okay, I'm gonna take left hand side of the question. So the left hand side of the question say 2 over this pen, man, instead of 4. Okay, so we have a 2 over a minus b. And then we got multiply by b minus a over 2. We have to prove equal to negative 1. So what I'm going to do, I'll take left hand side. Take left hand side of the equation. So what left hand side? So my intention here, I want to see if I can cancel this stuff and see if I can have a negative 1. So I'll take left hand side. So what I'm going to do, excuse me. What I'm going to do, okay, I'm going to write my 2 a minus b, and then look, this is a minus b. This a is positive, but this a is negative here. And remember, when they're equal, I can cancel them. But this is a positive, but this a is negative. So what I'm going to do, I will take negative out. If I take negative out, means this is going to be negative, this is going to be positive. So I'm going to put bracket, and I'll take negative out here, and I'm going to write another bracket. So if I take negative out, means this is going to be positive here. And this b, since it's just positive, is going to become negative. And then I still have my 2. Okay, here we go. So you see, they are similar now. A minus b. So if that's the case, remember here, between these two brackets, there's a multiplication sign. So I can cancel by 2 divided by 2 divided by 2 equal to 1. And then a minus b, and a minus b is like a minus b divided by a minus b. So it's going to be equal to 1 also. See? So I'm going to have a 1, and here's going to be 1. So 1 times negative 1 means this stuff here is going to give me negative 1 on top over 2, because this is going to cancel, but you still have a negative here, see, and this half is going to give me 2 over 1, so this is going to be negative 2 over 2 equal to negative 1. Or somebody else could have done say, okay, you know what, I'll do this. Excuse me, I'm right here, so I'm right there. Excuse me, I can take negative out of everything, so it's going to be negative out, and then we left with 2 a minus b. I hope everybody can see, and then we left with a minus b over 2. So this is the same thing, 2 and 2, a minus b, and this is multiplication. So for that case, we can cancel a minus b. That's in my line. Only when there's multiplication in between, this and this cancel. So everything equal to 1. So 1 times negative equal to negative 1. So we see left hand side equal to right hand side. Means negative 1 equals negative 1. So for that case, option A is true. Okay, let's go for the second one. For the second one, we'll try to make a space here, man. Man, this is stingy, man. Yes, but I don't have a lot of paper, so don't say, hey, man, you so stingy, man, because I don't have a lot of paper. Okay, so the second equation, they give us x. This is option B now. We want to see also if it's true. They give us x, just like how you show an equation, equal to negative 1 over 2, and a y equal to negative 2. So what we're going to do, we're going to substitute in the equation given. But the equation given is given negative x squared, and then negative x squared, and then minus 4 or x over y, and the plus y squared. So let's substitute those values of x, all those values. Okay, so for that case now, we're going to start to substitute the mean. So put in the mean, excuse me. So when you put in the mean, means you know the value of x, you're going to say negative. Okay, what the value of x? X is equal to negative a half, so it's going to be negative a half. But we have a square here, square. Everybody can see it. If you don't see it, please let me know. Minus 4 x. Oh man, x. So x equal to negative a half. Negative a half, but we have a y there. What is a y? Y equal to negative 2. So we're going to say negative 2 and the plus. What is a y? Negative 2 but square. So negative 1 square equal to positive 1, 2 square equal to 4. So negative 1 over 4 positive. Negative square is positive 1, 4. Minus. Negative and negative, positive. Positive and negative, because remember you multiply here. Or you could say negative times negative is positive. Positive divided by negative is negative. So the sign, we're done with the sign. We go for the number. 4 divided by 2 equal to 2. But we have only a half. Remember it's positive because we multiply all the sign. Means you're done with the sign business. Or you could have said negative divided by negative, positive, and positive means negative divided by positive, negative. So yeah, so now we go for the numbers. 4 divided by 2 is 2, and then we left with a half positive. So plus negative 2 squared equal to 4. Okay, so I'm gonna finish this question right there on top. So we saw what we have right there, excuse me. Or I can just finish it. Okay, so we have a negative 1 over 4, negative 1 over 4, because negative 1 over 4, and then this side here we have a 2 times a half equal to 1, because by 2 times 1 is 2 divided by 2 equal to 1, or by 2 divided by 2 you get 1, so just 1, so it's going to be minus 1 plus 4. Okay, so now negative 1 plus 4 equal to 3, negative 1 over 4 plus, which is equal to done already. So yeah, that's true. It's equal to 11 over 4, so equal to 11 over 4, and 11 over 4 mean is 2 3 over 4. So you can just say 2 3 over 4. Excuse me. So it's true. This option is true also. So we go for the last one. So we go for the last one. Get the paper quick, man. Time. Let's do quick. Okay, excuse me. The paper taking time to come out here. Okay. So the last option they give you, they say this function. Which function is this one? Here, 1 minus x over x minus 1. They say it's only defining. What is defining meaning here? Defining meaning is, excuse me, they say for all x are element of real number, but this x should not be equal to 1. That's how they say. It's not true. When they say x should not be equal to 1, I agree, yes, when x is not, or no, means x should not be equal to 1. Because when it's equal to 1, this stuff is not going to work, which is true. But not only when x is not equal, when x equal to 1, even some of the number doesn't work here. I'm going to prove to you, I'm going to disprove that it's not true. Okay, let's start with this one. When x is equal to 1, why they say this x should not be equal to 1? Because when x equal to 1 here is going to be problem, so this stuff is not going to be defined. How is going to be problem? Let's see. Let's put now when x equal to 1, let's see. So we're going to say 1 minus x. What is x? 1 over, and then this is square root, and then over, this is going to be 1 minus 1. So we're going to have a 0 square root, but we know the square root of 0 equal to 0. Same here, square root of 0 equal to 0. So 0 over 0 is a problem. This is indefinite. Undeterminate, apologies. This is undeterminate. I don't want to go deeper, but further you go, you're going to start something called El Hospital rule and all sort of stuff. But for now, don't worry about it. So for now, just remember, whenever you have a 0 at the bottom, is undefined. Whenever you have an expression and then 0 is at the bottom, then it's a problem. Or in other words, they say when 0 is at the denominator, is undefined. So, and what we see here, 0 is at the denominator, we have a 0. So for that case, this function is true that when x equal to 1, this stuff is not going to work. That's why in the question they say this x should not be equal. They say their x should not be equal to 1. But not only this one for this question, even the other one also does not work. I'm going to show you not only this one, even other numbers also does not work for this question. For example, if I put -1 here or -2 or even 0, this function is not going to work also. Look, if you put 0 here, it's going to be 0 minus 1 equal to -1. So look, let's put 0 when x equal to 0. When x equal to 0 here, it's going to be 0 minus 1. So at the denominator is going to be 0 minus 1 equal to -1. So you see, it's a problem already, because whenever you have a negative in the root, then this function is not going to be defined. It means it's not going to work out. In other way, in a simple language, when you say it's not going to be defined, meaning it can't work. You cannot define it, doesn't exist. So for that case, not only I agree, yes, this x when is 1 is the problem. That's why they say this x. That's why they say x should not be equal to 1. It's true, and we have tested here. It gives us a determinant which is undefined. But not only even when it's negative numbers. So for that case, it is true, but it's not enough. So they say the question they say that the given is defined for all x. For all x, not for all x. I disagree, because they say x is defined for all real number. But according to the question, this x, when it's 1, is the problem. That's why it should not be equal to 1. Not only 1, even when this x, any number which is less than 1 is the problem here. From 0, because if you put 0 here, the problem. Look, if you put 0, even when x equal to 0, like I say, it's going to be 0 minus 1. Even when you put -1, it's going to be -1 minus 1 is going to be -2. Look, at the denominator, it's going to be -2. Numerator, we don't care about numerator, so it's not going to work. So not only when x is not x equal to 1, even when x equal to negative number here does not work. So for that case, I'm going to take out the last one and say no, that's not true. So option A and B, they are true, but the last option is not true. Okay, so thank you. So let's go to the second question. So let's try to go for the second question right now, right? So the second question, excuse me. Okay. So the option for this question is going to be option 4, A and B. A and B. Option 4. Option 4, A and B. For the first question, it's option 4, A and B. Okay. Okay, let's go to the second question quick. Let's go to the second question. So the second question, like I said, this one I'm going to be doing all the time, man. Like I said, I couldn't afford a lot of pages. So the second question, so they say which of the following is true? Which of the following are true? Okay, so given that one, which of the following are true? So okay, that's the first one. We want to see if it's true, it's not true. and then the second one, and third one. We want to see if they're true or it's not true, or they're not true. Okay, these right here are option only A, only B, C, A, and B. Okay, I'll take it back again so that you can see the question. So for the first question, the option is 4. The answer is option 4 for the first question. Only A and B. Okay. For the second question, like I say. Okay, so we have that. We want to see which one is true, which is not true. Okay. Let's go to the solution. Let's go to the solution, man. We don't waste your time. Quick. Let's go to the solution. So solution. So let's go to the solution, right? Take my page quick, shows me. So take my page quick. Okay, second question. Okay, so for the second question, given, well, let's start to the A first, excuse me. The A given, x minus, also but can see, x minus y plus z over y minus x minus z, they say equal to 1. There's a lot of way I can do this question. If it's me, you understand what I'm saying? You know, if I had to do it to make it simple and less stress, you know what you should do? I'll give number all these values. For example, I could say letter x, let's say for example let. You want to make your life simple sometimes. X, let's say equal to 2, and y, let's say equal to x equal to 2, and y, let's say equal to 4, and z, let's say equal to 1. We just let, and then we're going to take this value, going to plug it in here, and then see if it's true is going to be equal to 1 or not 1. Okay, so let's go. So we're going to say set those values into the equation. So we say, okay, you just let those values. So what is the x? X equal to 2 minus. What is a y? Y equal to 4 plus. What is z? Z equal to 1 with over. What is a y? Y equal to 4 minus x. What is x? 2 minus z. What is z? Z equal to 1. So let's see if it's going to be equal to 1. If it's going to be equal to 1, it's true. If it's not going to be equal to 1, then it's not true. So there we go. 2 minus 4 is minus 2. Minus 2 plus 1, minus 1. So minus 1 over 4 minus 2, 2. 2 minus 1 equal to 1. Let's check again. Like I said, it's a multiple choice, and I don't like multiple choice. I'm not gonna lie to you, because you know you can make some silly mistake and then you out. But you know what? You don't have no option, so we have to do it. So let's see. X, did you substitute correct? X equal to 2, yes. Minus minus. What is a y? Y equal to 4 plus. Z equal to 1. We come at the denominator. Y, what is a y? Y equal to 4 minus minus x. What is a x? X equal to 2 and z equal to 1. Let's see now. 2 minus 4 is negative 2 plus 1 negative 1. Now we come at the denominator. 2, 4 minus 2, 2. 2 minus 1 equal to 1. So no, it's not true. So this, when you divide, equal to negative 1, and negative 1 is not equal to 1. Is not equal to 1. So for that case, A is not true. A is false. It's false. Okay, let's go for the B. For the B, we're gonna do the same game also, right? So for the B also, I'm gonna play the same game. So which game is that? So given 3A minus B, and the less than 1 over 3A plus B. I hope everybody can see. If you don't see, please let me know. 3A plus B. And then they say, if this is less than this, then that implies 9A, according to the question, minus B squared is less than 1. So we're going to do the same game here, man. Let's do the same game, you see. Okay. There's a lot of ways you can do this. Other way of different 2 square. But let's play the same game. So I'm going to let A equal to, okay, let's say 5. And B equal to 2. So I'm going to do the same game. So I'm going to start with the first part here. So I want to say the first part, 3 times A. What is my A? A equals 5. So 3 times 5 equals to 15. Let me do it straight away. So 3 times A equals equal to 15 minus b. What is a b? B equal to 2. We want to see if this is less than 1 over 3 times a. 3 times 5, 15 plus, what is a b? B equal to 2. This equal to 12 to 13, 9. Okay, 1 over 17. It's not true, because if you have it, this is bigger number, this small number. You know why I said this small number? This number here is less than 1. If you plug in a calculator, if you do by hand, look, you have a 1 orange and you have 1,000 people. It's like, it's gonna be 0.0 da 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 da. You can even plug in a calculator and see. Trust me. But of course it's a small number, because you have a 1 orange or 1 chocolate, and then you have like 17 people, so it's gonna be 0. Okay, let's go. So 1 divided by 17. So you have a 0.05. So this gonna be 0.06. No, it's not true. So it's not true. This is not true. No, excuse me. This is not less than this. Okay, but according to how they say if this is less than this, and then this must be less than 1. First of all, this is not true. It's not true here. Okay, let's take the other one. Okay, so the other one they say, let's prove this one also. So we say 9. What is a? A equal to 5. So 9 times 5 squared minus, what is a b? B is 2 squared. They say also this has to be less than 1. Okay, let's see. 25 times 9. 25 times 9. 225. So this could be 225 minus 4. So 225 minus 4. You get 221. So this could be 221. 221. And 221. Is 221 less than 1? No. And according to how they say, if this is less than this, then this is going to be less than this. In other way, if this is greater than this, then this must be greater than that one. So for that case now, let's see now. So how are we going to conclude that true is not true? Excuse me. Let's try to, okay, before we conclude that it's not true, it's not true, let's say find a number where these terms here is going to be less than this. But it's most of the time it might not happen, because whenever you have a 1, it's not going to happen, because this number by any means is going to be less than this. This must be greater. Any number you're going to substitute, this must be greater. Because you know why? You have a number, there's no way. So in my opinion, I would say it's not true. But please, man, just try to check out on this one. I just want also your opinion also. But in my opinion, I don't see any number whereby when you have a 1 divide, for example, let me give you a vivid example. So I'll say it's not true, but I'm going to show you I'm going to show you a vivid example. But please, I just want your opinion. So write down and tell me what you think. But in my opinion, say this is not true. Why? Look. So, no, it's not true. So if I had to pick, I'll say it's not true. Okay. Because they say if that number is less than this, and then for that case, then this, it's going to be less than 1. No, it's not true. I say it's not true. True opinion. Okay, let's go for C. So A and B is not true. Okay, now we go for the C. So for the C given, we're going to do the same game now. For C, they give us P squared minus PQ, and then plus Q squared. They say this is equal to P minus Q squared. Come on, this is more easy. So what I'm going to do, I'll take right hand side and then try to expand and see if it's going to get to here. Okay, so for this case now, take the right hand side. So take right hand side. So say right hand side is p minus q square. But what that means? This meaning p minus q times p minus q. Okay, so let's multiply now. The first one with the first one, it's gonna give me p square. The first one with the second one, so p times negative pq is gonna be minus pq. Now account for this one, for the second one. Second one with the first one means negative q times p. It's gonna be negative pq. The second one with the second one means negative q times negative q, which is gonna be plus q squared. So these are like terms, and they both have a negative, so we bind them together. So they marry them together, so it's gonna be 2pq plus q squared. No, it's not true. So right hand side is not equal to left hand side. So for that case, it's not true. So we see none of them is true. But let's check the options now. Option 5. So none of them. So option 5. Option 5. I'll go for option 5. None of them. So question 2 is option 5. Let's go to question 3, man. Let's go, man.